So because this axle is 5 inches wider than stock, I'm going to need to lengthen these CV axle shafts. So these are Rzeppa joints with a solid shaft, and the shaft needs to be machined to be 2.5 inches longer for both the short shaft and the long shaft. So the question comes as to what steel I'm going to use to make these axle shafts. So I've chosen this D2 tool steel. Now D2 tool steel is actually stronger than 4140 chromoly steel, but D2 tool steel is much more brittle. Now if you look in this graph over here, you can see the torsional strength of D2 tool steel, and you can see how strong it is. The problem that people have with D2 tool steel is firstly the brittleness, and secondly the costs, and thirdly the difficulty to machine it. So people will complain, I guess, that I'm using the wrong steel for these shafts, but I think that these will be probably about the same strength as chromoly steel. But ultimately, I think it will be much, much stronger than the stock steel that comes with the OEM shafts. So I need to clean these out to disassemble them, and according to the factory service manual, you must, or wherever I read this, you're not supposed to ever remove this grease with a solvent. The problem is there's no other way to clean these, and these are in perfect working condition. You just got to clean out all the crap. I discovered that gasoline works perfectly for this. It fits nicely inside the cage. Okay. And then we take a hammer and we just go like this. What you have here is a snap ring, and that makes it easy to get everything off. $70mm longer, which gives me a little bit of room to face off the ends. So I've now machined the passenger side drive shaft, which goes away all the way to the end of this lathe because it's so long. And this is the driver's side, which is the short side. And I've done all the cuts, and everything seems very close to the other one, within about 1 or 2 thousandths of an inch. On both of these I've left the seal surface slightly larger, which I plan to sand down as a last operation. So I've left it a few thousandths over. I've also made these areas where the spline is cut slightly bigger because there is actually room for more. I don't know what the effect is of that, but I think it will fit. Now I'm doing the very last operation here, which is just this chamfer on the edge. And this is important because when you push this through the seal, it mustn't be sharp, otherwise it's going to cut the seal. So this is the last operation, and then we're basically done. And now I'm basically done. Okay, so this is now going off to the machine shop, and hopefully they'll do a job at a reasonable price to get the splines cut in. I'll just show you the comparison between the two. Here's my piece, and here's the original OEM piece. I sent these out to get the splines cut, and the splines came back, and now I'm going to finish off the seal landing area, which has to be a precision surface. So I think that looks quite nice. So there we go. So after getting these machined, I sent them off to heat treatment. They came back like this. So when they come back from the heat treatment, you can see they're not shiny anymore. They've got this kind of slight scale in it. This is a vacuum heat treatment process, so there's very little corrosion. Obviously you can't have these oil quenched because when you heat them up in the furnace in an oxygenated environment, you're going to lose a lot of surface accuracy. So for this type of metal, D2, you want a vacuum heat treated process. Now the problem with heat treatment of any kind is that you get warping of the shaft. So here you've got the longest shaft, and if you look at the dial, you can see there's closer to 23 thousandths. I'm reading here 19 thousandths. Which is a bit too much. Now actually I did measure the factory shafts, and they're also out by a little bit less than this. You want to bring these in within 10 thousandths. The reason is because that is what the aftermarket manufacturers of these shafts bring their shafts to. And 10 thousandths would be a good straight. What I'm going to do is I'm going to press this, and I'm going to keep pressing in increments of 20,000 until it doesn't spring back. And that is the process I'm going to do. I'm first going to heat this a bit because apparently heating the shafts reduces your risk of cracking the shafts. I bought these V-blocks on Amazon. These are crappy cheap ones and not particularly hard. This should be good enough to do some bending. Okay, so now what I'm going to do is I'm going to heat up this shaft to 300 degrees Celsius, which will very slightly upset the temper, but it seems to be a good temperature to bend the shafts, because if you heat it up cold, I've heard that you've got a much higher risk of cracking. Now get it even heat, I'm going to run this on the lathe. Now of course the ends of the shaft, which are critical to this whole thing, are never going to get anywhere near the temperature of the center of the shaft, so I don't think I have any concern to upset the temper of this end, which is where the maximum stress is over here. .1 inch. So 0.1 inch did not bend it. So now we can go to heat it again and go to 0.2 inch. See what happens. Okay, it's at 75 degrees, so it cooled down quite quickly. Nope. 0.12. No. Point 1.3. No. Okay. So now we're on 1.2. We've got some movement. Well, that's good. Okay, well, let's get some more. One. Two. So I'm going to hold it. Now apparently holding it is quite important because it allows the molecules to kind of find their position. So there's definitely bending. So we're within, we're at 0.9 now. So 0.9 is actually good enough. Well, I'm going to go 1.4, so I'm going to go 0.24. And then I think I'm done. One, two, and 3, 5.4, and hold. Okay. 1.8. Okay, so 0.45. One, 2, 2.1, 2.3, 0.4, 0.45, and just hold. The weird thing is that it doesn't move it, and I find that quite strange. Okay, 2.75. Okay, so now this is in 2000s, which is very good. Take this up to 2, and I'm going to let it cool like that. Let's let it cool for an hour. Let's see what the dial reading is. So I've gone ahead and put a pressure at this point in the shaft. So I've kind of bent in the middle, and then I've bent over here. There seemed to be like a turn. So bending in 2 places was useful, and it was also useful not to fully bend it straight at any one point, because then you're actually overbending it. So I bent it over here, and using the same procedure. So I messed up slightly. This ring pin groove is slightly too shallow, so I'm going to line up the Dremel tool, and I'm going to try and see if I can grind it to the correct depth. So I got a bit paranoid about possible leaks, so I'm actually going to polish this seal landing area. I have installed this now with the bearing and the hub mocked up, and I wanted to see where the seal landing area was. And if you look here, you can see that the seal, and this is a bit of Prussian blue spray, and you can see the seal has come to about halfway over the seal landing area, which is just perfect. So the final step is the assembly of the boot and the Rzeppa joint and the shafts. Now, these boots seem to be the best boots I could find. They're called MP. They come with grease, which I'm not going to use because I have my own grease, and we're not just supplementing the grease and replacing the boot, we're actually replacing all the grease. So I need a lot more grease than I have here. They come with these collars, and I mean, this requires a special tool which I don't have. So I'm going to be using these ones, which are a lot easier to use and get right and get the tension right. These ones are wraparound, and I've got the tool for this. And they come very nicely with the correct locking rings. So I was quite impressed by this. I didn't realize they came with the locking rings, and this is very useful if you lose a locking ring. So I'm going to use this new locking ring. And the other one is difficult to get off. I'm going to leave that. This is so full of grease now, it's actually squeezing out. Now we've got to put on these things. So this is the tool. You don't need the fancy one. This one's only about $10 on Amazon. So I don't need all that length. So we're done. One mistake people make is they put on this locking band, and you must never put on this band before you put it in the car, because with this band on you can't actually fit this through the bearing. So you withhold putting on this band until after you install. Okay, so our custom CV axle shafts are now done. Job completed.